Hi guys, I'm Gal Broder. I'm the senior sales engineer at Sepio Systems, and I want to show you today the Sepio solution, the hardware access control, the Hack One, and all the benefit you can gain from getting full visibility for all the assets that you have, detecting on frog device, and control the assets that you have. And before I start, I want to show you what I have here on my desk, so it will be clearer later with what you see on the user interface. So I have the Dell computer here, which is protected with a Sepio agent to protect from all the peripherals and gain all visibility of the peripherals that are connected to this machine. I have Cisco switch here, which is connected to many more switches on the room next to me. To this switch, I have all connected to the network, like the Cisco industrial switch, the Moxa Modbus to TCP, and the ABB industrial controller, all OT devices. I have a computer here that will demonstrate an attacker device. I have some rogue devices here, and we'll talk more about them later. I have the rubber ducky device here, and I have the plunder bug as man in the middle attack device here. And we'll talk about it later when we will dig into the network detection and peripheral detection. Now let's skip to the user interface of the Hack One, the hardware access control. So I want to start with the big picture, with the like list of all the assets that you have. And here on this screen, you see visibility for all the assets that you have, like network switches, like network devices, peripherals, endpoints. Everything is listed here. And you can see we have many details on every device, like the time frame it's being connected, the location. Speaking about location, it can be like a host name if we talk about peripheral, or if we talk about a network device, it will be the switch name, IP, and the exact port where we find this device. Now we can play with it and create whatever reports that we want. We can say, okay, I just want to see peripherals, or I just want to see network devices. Or we can filter by category, for example. I can click on the camera, on video, for example, cameras, and then I can see all the USB cameras, all the IP cameras that I have in my environment. And this provides a great visibility for any company that today, really most of the companies, they walk in the dark. They don't know what is connected in their environment, especially when they have tons of employees today that work from home, or they have the bring your own device policies. People, they don't know what is connected in their environment, and this provide them great visibility for it. And it's easier to control once you have the visibility, because once you don't know what is there, how can you control it? Let's speak more about the reports that you can get here. Like you can see, there is a grade outline. And what is the grade outline? As you can see, we show if a device is connected, if it's online, or if it's not connected, if it's offline. Now, why do we keep in this list even offline devices? Because you want to track. For example, a contractor arrived with a flash device and connected it, I don't know, ran some update on several endpoints. You want to know after he left where this device was plugged. You can always filter by this device, and then you know exactly the time it was connected and where it was connected. Now, other than this, let's say you have a very secure facility, nobody should be there during nighttime or during the weekend. You can always filter by time to see if there is a new devices that has been plugged during nighttime or weekend time. And then you know more or less the risk that you have. If you see some activity during off hours, it should say something for you. Now, other than that, you can see here that every device has a risk level between 0 to 100. The risk level can be set by several factors. It can be vulnerability of the device, it can be a non-attacking device, it can be an endpoint with many unapproved peripherals, and there are several factors that determine why the risk level is what it is. And we explain it in the risk description. Now, let's go and dig in a little bit more about the detection of the network and the peripherals. But before that, I want like few words about Section 889. Section 889, it's a new section by the government that force any federal agency not to work with specific Chinese brands. They ban some Chinese brand, and the problem is that there are no tools today to figure out if you use such of tools, such of devices. But Sepio can really help in this. Why? Because you want, for example, to know if you have ZTE brand that in place, all you have to do is just filter by the brand name and you can see if you have something like that in place. And it doesn't matter. It can be any like Dawi, Huawei, like Xiaomi, like any device that you think that you want to monitor to see if you have, you can see. And then the nice thing, you know exactly where it's connected to. Okay, now let's go to the endpoint and see what we see on the endpoint. I'll go to the computer that I have right in front of me, and we can see all the peripherals that are connected to these devices. Now, together with our agent, and soon we'll have the agentless solution as well, we can mitigate devices. For example, I don't want to let any Dell keyboards to be plugged in my environment. I can set the policy that Dell keyboards are not allowed. I can do it per agent, I mean per endpoint, or per cross organization. Like I don't want anyone in my organization to use Dell keyboards. It's possible. It's just matter of policy. Now you can see on the list of the peripherals that I have some alert here. The alert I have is what seems to be like a Logitech keyboard. And we say it's a Logitech keyboard by the vendor ID and the product ID of the device, the VID and PID. Now, any endpoint security solution, they trust on the VID and PID. They trust the device to say what it is. The problem with that is there are attacking devices that they will never tell you that they are attacking devices. And if I go over on the alert here, we can see it's a rubber ducky. And how we can see it's a rubber ducky and not Logitech keyboard? Because we monitor the physical layer information of the connection. And then we determine, we fingerprint the device, and then we see the fingerprint is similar to a rubber ducky. And then we know it's actually a spoof device, and we alert and we can mitigate it, of course. Now, if you have endpoint security solution and you whitelisted the Logitech keyboard, once you will plug this device, it can run any script. And actually, it's a keystroke injector, whoever doesn't know this device. It's a keystroke injector. It's like a keyboard. I preload it with scripts. Once I plug it in, start to run scripts on the computer. And this is a huge risk for organization, a huge risk from a small device, very cheap device. Okay, so let's continue to the network detection. And now I explain how we are different from any endpoint security solution that they trust the device what it is, and we don't trust, we check what the device truly is. Now I want to show you how we are different from any NAC solution. And I'll go to the network. And first, before I go to the network, I want to show you this plunder bug device. This plunder bug device is connected as a man-in-the-middle attack. It's a small tap device, doesn't have any MAC address. It's connected between the computer with the white wire to the switch with the black wire on the first port. And as you can see, there is a USB cable here going to the attacker device. This device, it uses a USB, but it can be like device with cellular chip. So the attacker can connect to it remotely. It can be with Wi-Fi. There are many different devices similar to this. Now, just I want to show you the switch, for example, what we see on the switch. So let me log into the switch. Sorry. And you can see on the MAC address table that on the first port, all I see is just one MAC address. I don't see any other MAC address. This MAC address is the MAC address of this device, of the computer I have in front of me. Now, if I go to the attacker computer, you can see I have a Wireshark here, and there is a virtual Ethernet adapter was added to this machine. Once I go to this virtual Ethernet adapter, I can see all the traffic that going through this device. Now, nobody is aware about this device because it doesn't have any MAC address. NAC solution won't detect it because the switch is not aware it's there. Now let's see what Sepio sees, what the hack one sees on this switch. So I'll go to this switch and I can see, other than the full map of the switch and everything that is connected to it, I can see I have an alert on the first port. If I go over on the alert, I can see there is a plunder bug connected here. We still see the computer and we gather more information from our agent, and you can see the type of the computer, the IP, host name, etc. But we still see the alert on the plunder bug. And this is how we can fill the gap that NAC solution they don't have. They don't have the physical layer detection where we detect the devices, because we grab the information, the physical layer information from the switch. We don't monitor any traffic. We don't care about traffic. We gather the physical layer information from the switch. We fingerprint every device that is connected to the switch, and then we tell you exactly what the device is. Now, we want some control as well. So speaking about control, we create a policy verification management for the network. Here I can set policies that have sets of switch commands, switch commands that I want to see or I don't want to see on a specific port or for a specific MAC prefix. For example, and I created very simple example. First policy, switch port access VLAN 9. If I will apply it to a port, once it will be on VLAN 9, I won't get any alert. Once someone will change the configuration of this port, and it won't be on VLAN 9 anymore, I will get an alert. Now, speaking about section 889, it can be very helpful. Why? I created here simple policy, no access. In this policy, I said that I don't want to see any switch port mode access command for this policy. Why? Because I don't want any Chinese brand to have an access to the network. Now I created a list of MAC prefix for the specific brands that are on the section 889. And I applied this policy to this MAC prefix. Now, every time we will find this MAC prefix on the network, we will check this policy. If there is a policy mismatch, we will alert on it. Let's see how it looks like. I'll go to the switch where we connected many Chinese devices, and you can see all the red dots. Now, if I go over on the red dot, you can see here, for example, there is a Huawei device, and you can see there is a policy mismatch here. And policy mismatch on the no access policy, and there is a forbidden command but present the switch port mode access. And this is how, like, even if you know you are clear from any brands that you don't want to use, but you want to monitor if someone will plug it in, with this tool, you can monitor and get alerts if something is plugged in. Now, let's talk a little bit more about what other risks are available from you together with risk knowledge together with the hack one. So we know everything that you have that is connected to your network, to your endpoints. So we want to bring you more knowledge about the risks that you have, not just rogue devices, because sometimes you have vulnerabilities in devices, sometimes you have legitimate devices that can be harmful, and people sometimes are not aware of it. I won't show it all the risk inside, just few of them. Like, for example, the list of vulnerabilities of peripherals. Here we show you not rogue devices, legitimate devices that have vulnerabilities, like the Logitech Unifying Receiver. We show you the list of vulnerabilities that it has and where you can find it connected. Now, you see only relevant information for you. You won't see any device that you don't use here. Only devices that you use, you will see here. Speaking about vulnerabilities, we already have access to your switches. So we know the brand name, we know the firmware version, we know the configuration. So we maintain and we keep you updated with vulnerabilities that you have on your switch. We filter all the CVEs or vulnerabilities per switch, per firmware, per configuration. Because for example, if there is a vulnerability, a CVE on telnet, and you disable the telnet, you won't see it here on the list of vulnerabilities. And we have several customers that they told us they waste so much effort in like getting the information and then to filter it per switch, and they need to check the configuration. We do all the hard work for them. With this, you can like just click on the switch and you know if you have vulnerabilities on the switch. You want to get more information, you just click on the vulnerability, takes you to the NIST website to get more information about this specific CVE. Now, all all the information, all the alerts that we have, it's been reported to the event log. The event log can be exported to any SIEM environment, like syslog, Splunk, or whatever. We, we support several protocols to export all the event log to any SIEM environment. And we have open API for everything that you see here. So basically, in the matter of integration, the potential is endless. Other than this, sometimes you want just to get like a report to your email. You can set in the scheduled report your SMTP server, and then you can set who you want to get the report and when, like days, times, and how frequent, the interval that you want to send the report. And then you get the report in a nice PDF format. There are some pre-scheduled reports we are open to add, and we keep expanding more and more reports to this list. I think I covered like the most important thing of our technology. I hope it was clear enough how we are unique and in the matter of detection and the risk insight that we bring. And I really hope you will find it helpful. And I hope to talk soon. Bye bye.